So can you hear me now? Just checking if the microphone is still working. Perfect. So in the absence of the chair, at the moment, I will be your host. I remind you that you have 15 minutes for each presentation, at the end of which you have some minutes to discuss eventually if someone has questions. So if you want to start sharing your screen and the slides, feel free to, so we can actually start with the session. Thanks. You can open your mic.
Can you hear? Hello? Can you hear?
Okay, I can hear you. Okay. You can start whenever you want. Okay.
Okay. Good morning. My name is Tawane Santana, and I will present the work A Qualitative Study on CSML based on perceived views from industry professionals. This paper brings new reflections of a survey on what professionals think about CSML when used in practice. The survey received responses from 344 professionals from 38 different countries. 163 participants left their written general comments on CSML. These comments were divided into positive or negative for the language. Based on this categorization of comments, we performed a qualitative analysis of the positive and negative responses, and then proposed a code word for each type of statement. The system model language is an object management group standard proposed over 15 years ago. It is an extended subset of the UML that provides a graphical modeling language for design complex systems, considering software, people, process, hardware parts, and other system elements. CSML supports the specifications, analysis, design, verification, and validation of a wide range of systems, allowing you to model from different perspectives such as behaviors, structure, or requirements. The motivation for this work came from the lack of research on the evaluation of what industry professionals think about language that are effectively using CSML in their daily tasks. Most studies on CSML are domain-specific or only consider toy examples or even do not evaluate CSML as a modeling language in their examples. The results of this research were obtained through a survey which main objective was to seek quantitative and qualitative information on the use of CSML all around the world. The survey was conducted online through Google Forms and was available between the months of November 2020 and February 2021. The form was emailed to the authors of Google Scholars 100 most relevant CSML papers. It has also been published in language-related LinkedIn groups. The survey was also sent by direct message to professionals who have the term CSML among their LinkedIn profile competencies. Participants were asked to leave, in a non-mandatory way, a general comment on CSML. The comment sought to identify, from the point of view of industry professionals, what are their motivations for use CSML, expectations about CSML future, in addition to the flaws and benefits perceived by them when using CSML. The survey received responses from 244 professionals, 38 different countries. 163 participants left their written general comments on CSML. The comments were divided into 70 responses were categorized as positive, 72 as negative. 45 responses were discarded because they did not contain relevant information to this research. This figure shows the diversity of countries where the professionals who responded to the survey were. It is possible to identify in most of the positive responses a statement about the usefulness and benefits of CSML. Most participants described the language as powerful, detailed, consistent, and broad. This picture depicts the word cloud for positive responses of the survey. Most of the participants highlighted the main negative point of CSML as its learning difficulty and complexity, especially for beginners and non-specialized people with training in different areas of system software engineering. It was alleged that there is short experience in industry regarding to the language and that it requires a great amount of specific knowledge for its effective use, in addition to a steep learning curve. The figure depicts the word cloud for negative responses of the survey. This article carried out a qualitative analysis through a survey on what industry professionals think about CSML when used in practice. Through the collection and categorization of the comments received, positive and negative, it was possible to identify gaps and different perceptions about CSML. This research can provide confidence to those who are considering investing resources to introduce CSML as a modeling language into the software and systems development process. Through the qualitative analysis performed, it's possible to see that despite having great advantages in its use, CSML still has some gaps that need to be studied and depended so that the industry can expand its use and that more professionals recognize it as valuable language. Further research should be performed on the subject of difficulty of using CSML in practice, including its learning curve, comparison to other model language, effective use, and every detail that can be considered when one wants to learn how to use CSML in a project. Thank you for your attention.
Hi, Andrea. Can I go ahead?
Yeah, I can hear you.
Sure. Thanks. Okay. Thank you very much for that beautiful presentation. It's Jay Pensham here. What is the main contribution of this research to the industry?
Do you repeat, please?
What is your major contribution of this paper to industry, to business world?
And show positive and negative statements about XML.
Okay. All right. And how does it compare? What advantages will it give to industry using this model SysML?
Then a company can use it knowing about XML.
All right. Okay. Is there any other questions from any of the other participants and audience? Please go ahead. You can raise your hand. Okay, there don't seem to be any other questions. Thank you very much for your presentation. Are there any other presenters in the room? Cool. Wakar Ahmed is not here.
I see there is
Idris is here. Yes.
one presenter for the next presentation. So
Sorry, your name is?
I'm afraid to pronounce the surname wrong, so I take the liberty to call you Idris.
Idris, yes. Idris is here.
So
Abdul Mimin.
feel free to start and share your screen as soon as you want.
We cannot hear you if you have... Idris, can you hear us?
Okay, we can see your screen, but we can't hear you. So check if your microphone is correctly on. And if it's working with the browser correctly. You can also check the microphone settings to see if there is any issue with that.
Is on.
Okay, we can hear you. You can start now. Oh, it was another person, sorry. So
No, that was
yeah,
Jalil. Sorry. Yeah.
I've seen it. So
I think it is, well, his phone is enabled, but we can't hear him.
we can just see your screen and not hear you. Please check the microphone settings, the little arrow near the microphone and check if the microphone is correctly set within Jitsi, please.
You have selected Microsoft David as default voice.
Okay, we can hear you. We can hear you.
Oh, there we are. We can see your screen now, but we cannot hear you. Still.
Can you confirm in the chat room that at least you can hear us? Okay, okay. I think we can wait for the presenter to join us again.
Oh, he's left us here. Habib.
I'm here, but I'm going to join to my other in Indonesia, right? So I'm just checking it. Nobody is there, right?
Idris was here, but he had a problem with his mic, so we couldn't hear him. We could
But
see his presentation.
I can't see. Okay, so he presented.
No, he hasn't started.
Okay, so the last one is there.
Yes.
Only the
Michael or Michelle Soares presented only.
presented.
Yes.
Okay, so good.
Yeah, we have the one only.
Okay, Michael has presented. Okay, yeah. So Idris is there. George Boulay is not presented, right? The first two has not presented. So Idris is about to come.
Wakar Ahmad. No.
No, Ricardo has replied. They have some problem. They have some issues there. So he will
Okay.
not present.
Okay. All right.
So I cannot join to the two online session in the same laptop. So I may be quit.
Sure.
Only Idris is remind, right? So let me go there.
Okay. Okay.
It's okay. Thank you so much. Okay.
No,
Once you are there, I am confident, right?
no problem. Just leave it to me. Yeah.
It's okay. Thank you.
Okay. Idris is back. Idris, can you hear us? We still can't hear you.
Yes, I can hear you.
Oh, very good, very good. Okay, we can hear you now. You can share your screen and please, you can commence.
Okay, I have to use my phone now to present, so let me get things ready now. Hello, can you see my screen?
Yes, we can see your screen now.
So I am presenting a paper on data selection as an alternative to quality estimation in self-learning for low-resource neural machine translation. So I hope everything is clear.
Sure, you may continue. Thank you.
All right. So machine translation systems are relied upon nowadays to generate translation between languages, but many languages don't have sufficient to train these systems to achieve optimal performance. So one of the methods that were proposed to solve the problem of lack of sufficient training data is self-learning. So self-learning is a method where a model is used to translate monolingual data, which usually is much more available than the parallel data. And the data is then used to improve the performance of the generating model. But the problem with this is that machine-generated translations usually contain many errors. So we need a system that will enable us select the sentences that will give the best performance. So research by UFN 2006 and Special et al. Introduced the quality estimation in the process, whereby the generated data is cleaned, meaning only the qualitative sentences are selected and used to improve the generating model. So, but the problem is many low resource languages do not have a quality estimation system. So this may therefore limit the implementation of the solution. It also a problem is we have to translate all of the available monolingual sentences, although not all of the sentences are needed. So in this paper, we try to solve the two identified issues. One, the absence of quality estimation system, and secondly, the translating every data, even though not all of the data is needed. So we introduce data selection. So the data selection is a process of selecting from the available data, the data that is needed. So in this case, data that is needed is data that have the same or similar domain as the testing set.
Idris, we lost your video, your presentation. Can you still hear us? I think he's got a problem with the internet connection because we lost him.
It seems so, unfortunately. We can wait and let him finish.
Connect, yes, okay.
Hello.
Hello, Idris. We can hear you. We lost him again, I think. Hello, Idris. You're back now. We lost you for a while.
But it seems that I presented only to myself.
We've seen a few slides, and then we lost your connection.
Yeah, the problem is I'm using my phone to do this. My computer, I don't know the problem. I tried a lot to rectify the connection and the audio, but it was not working well. So should I present again?
You can continue from where you stopped. I think it was about the third slide.
Okay. Do you see my screen now?
We see your phone, not the slides.
All right, yeah. Let me open it.
We're almost there. Yes, okay. It's a bit
So,
small.
which
That's fine. Carry on. Next slide.
am I in?
The next slide. Yes, we were here. So you can carry on from here.
Okay, so to conduct the experiment, I said we use the IWS LT data set. Is an English-German data with 153,000 instances, training instances. So we use for the monolingual data, we use almost 400,000 sentences from WMT in English data. So we build the models using the LSTM, which is so with long attention. We use pre-training and fine-tuning. Pre-training on the synthetic data or the additional generated data, and fine-tuning on the original data that we have, which is this 153,000 sentences. We use Bluemetric to evaluate the performance of the models. So the results that we obtain here are after using all of the additional data, which is the synthetic data, to implement self-learning, we got a result that is almost 2 times the performance using the baseline training on only the authentic data that we have. So after implementing the quality estimation system to select the best sentences to implement the self-learning, we obtain more than 2 blue improvement. So we implement using our own proposed approach. We saw that the performance improves over the baseline and using all of the synthetic data, but it slightly underperformed the quality estimation enhanced self-learning. So we also implemented the iterative self-learning with quality estimation as proposed by Specia et al., but using the pre-training and fine-tuning approach of Abdulmumin 2019. So we implement using the quality estimation and using the data selection. And from the performances here, we see that the results are comparable and even better in some instances. After the second iteration in self-learning with data selection, we achieved a performance that is better than using quality estimation by almost more than 0.2 billion. So we also implemented a variant of self-learning with quality estimation, and also using ours. We only use the best data, best synthetic data at each approach. So and using our own proposed approach, we use the closest monolingual data. So we obtain a performance that are comparable and even better in some instances, as shown in the table. So we see also the time taken to implement both approaches. Using quality estimation, we require a time of more than 2 days in the best case, while more than 4 days in the worst case. In our own, for the 2 implementations, we require only above a minute to sort this data into how close their domain is to the test set. So we use the models as backward models and use them to generate the additional data to implement a back translation approach, which is another approach similar to self-learning. that improves the performance of translation models. So if we see from the scores we have from the performances are comparable and in some instances even better in our own proposed approach. So for the conclusion, we saw or we were able to show that data selection is simpler and even faster and also more applicable alternative to quality estimation for improving self-learning in low resource neural machine translation. We saw that the approach can be deployed in back translation to improve performance of the backward model, so and ultimately the performance of the forward model in back translation. So for future work, we suggest that the ideal amount of monolingual data to be selected, or the ideal amount of to be selected to achieve the best performance. In our work, we use only a third of the whole monolingual data, which is in the region of 133,000 sentences. We selected 133,000, which is a third of the available monolingual data to implement our approach. So it will be good if the ideal amount will be experimented and found. So we also suggest that the approach should be implemented to improve high resource neural machine translation, because we only considered low resource machine translation in our work. So thank you for giving me the opportunity to present.
Okay, thank you very much, Idris. Are there any questions from the audience? I think we have only Marco here, Simonetti. This was a good presentation. Well done on your research. What level of study are you at?
I am a PhD student, so I'm concluding my PhD work.
Okay, sounds very good. All the best for your studies.
Thank you.
Andrea, I don't think so there's any questions, and there's no other presentations at the moment. We almost time.
Yes, we have
10 minutes.
a little break now.
Sure. Okay.
So we can wait until
10:15.
the next session.
Okay. Okay. All right. Thanks.
Resume at 10:15.
Sure. Thank you.
Central Europe time.
Thanks.
All
Okay.
right.
Thanks. Bye.
See you later. Okay, we can resume with the next session. If anyone can hear me.
Yes, sure, I can hear you.
Perfect.
Let's see who we have here. Are there any presenters in the room? We have Sergio. No. Is George. Savio, Veronica, and Walter. Any of you here? No,
I don't see. So let me check with the schedule. Can wait a couple of minutes more, and then in the meantime, I am searching for what you asked me.
Yeah, I noticed that the others have got it on the slides, and I see you got it on your desktop as well.
Mhm.
The one that I picked up had a black background, square background, so it didn't fit in quite well.
I asked the organizers if they can provide me with an image or a link, so I can.
Okay, I did see some on the internet, on page, but I didn't find the one.
But I'm pretty sure they have the resources,
Yeah,
the
somewhere.
file somewhere.
Sure. Okay. We have a gentleman who's just joined us. Do you have a paper to present, sir?
Yeah, this is Kennedy.
Sorry, your name again?
Yeah, my name is Kennedy.
Which paper are you presenting?
Okay, I'm presenting a paper on just 1 minute.
What time is it?
Okay, yeah, 15:45.
15:45.
Okay.
Okay, that'll be later on.
Just a friendly reminder: when you join the chat room, please change your name from fellow Jester to Gister, sorry, to your actual name and surname, so we can.
Okay, in my case, I don't have option to change my name. There's no option for doing that name correction.
I see. You can. I'll share my screen and show you how to do that.
Is that
Oh, great.
Gibeon? Is it Gibeon?
Oh, great.
You can go here, settings. You can see it in Italian now, but it's the same icon. Settings.
Okay, settings. Okay.
Profile, and then change your name here.
Oh, great. Okay, that's fine. Thank you.
No problem.
Thank you.
Thank you.
Oh, great.
So I see there is Gibeon Aquino. Are you presenting the paper name entitled "The Classification Aspects of the Data Offloading Process Applied to Fog Computing"? Is it correct?
Yes, it's correct. Good morning for everyone.
Welcome.
Yes.
Good morning. But he's presenting at 15. Not in the session, is it?
I see it at 10:30.
Oh, sorry. Give me a second. Classification of aspects of data uploading process.
So we can wait just a couple of minutes to see if the previous presenter join us, and then go ahead with the second presentation.
Okay. All right. Okay. No, that's fine. We can actually start, and if the presenter joins us, we can slot the presenter after this
Perfect.
presentation? Sure.
Okay.
Please go ahead. Welcome, and please go ahead with your presentation. Thank you for joining us.
You can share your screen and start if you want.
Gideon, can you hear us?
Oh, sorry. Just to confirm, I am the first to present.
Yes, you may continue. The previous presenter is not here at the moment, so you can commence. Please share your screen and continue.
Okay, are you seeing my presentation?
Yes.
Okay. May I start? Just to confirm, I have 10 minutes to present.
Yes, you may start. Thank you.
Okay. Just a minute. Okay, good morning for everyone. I am Gibeon. I'm here to present the paper classification aspects of the data offloading process applied to fog computing. This paper resulted from a study performed in a master program in the University Federal of Rio Grande do Norte. We are in Brazil. This university is in Brazil, and this work was resulted from a researcher performed by Savio Melo. He is not present here, but I'm going to present the results, and I'm trying to give you overview of his researcher. Okay. What's the context of this research? We applied all the research on this context. What is the context? Is the context of a regular fog application of fog architecture, where we typically have some devices who produces and process data, but in order to improve the latency to store the data produced here, we can create a fog layer to be close to the devices and improving, for example, the latency of stored data. But on the other hand, we have some limitations related to this device because they are typically with storage restrictions. And for this reason, what's the main problem related to fog architectures is the problem of how to decide when you you delegate the processing or the storage to another layer, typically the cloud layer, because this layer there isn't restrictions in theory, and sometimes you need to do the offloading. There are two kinds of offloading. You can offload the data, or you can offload the processing, depending on the context, depending on the application. But in our research, we focused in the problem of data offloading, the problem of performing data offloading to the cloud in order to release space in the fog layer. It is the main focus of our work. And the main problem is the data offloaded dilemma. What this dilemma is? You need to decide when you transfer or when you keep the data. Sometimes you have problem of space, but you cannot release the data because the application, the devices layer here need the data, and you cannot simply release the data. You need to keep the data because it can be it need to be it need to be used by applications in this layer, and you cannot simply release the data. But sometimes you can transfer the data. For this reason, you need to decide when you transfer, when you keep the data. And there is another question or another dilemma to decide which data you transfer or which data you keep. Sometimes you have a lot of data, several different kinds of data, and some kind of data you can keep, and another kind of data you need to transfer. You have to choose which one you transfer and which one you keep. And another problem is how to transfer this data or how to keep this data, depending on the security requirements, or depending on the infrastructure that you have. You need to you have different ways to transfer or different ways to keep. And for the reason, there are several decisions that you have to make in order to have effective data offloading. Sometimes you transfer, sometimes you keep, but even when you decided that you need to transfer or you need to keep, you have a lot of different options how to transfer, how to keep, which data to transfer and which data to keep. It's the main problem that we are focusing. And related to this process of data offloading, we identified that you need to have well-defined policies. You need to have specific policies well-defined to do effective data offloading. You cannot just do a simple decision based on specific requirements. You need to evaluate all the aspects and create specific policies to do effective data offloading. And these policies may address important issues such as security, storage restrictions, data lifetime, infrastructure, data privacy, latency, and several requirements that influences the way how you do data offloading. And for this reason, our specific research problem addressed in this paper is the first one is because several issues must be considered to design a data offload process. You have different techniques. They are some of them are defined in the literature, but this knowledge is very dispersed, and without a clear guidelines. You have most of papers that we found focusing the problem of process offloading and not data offloading. And for this reason, we identified as an opportunity to organize this knowledge and give some guidelines to researchers and the practitioners to have a good organization of this knowledge related to data offload in foggy layer. Okay. And the main contribution of the paper is the definition of a taxonomy that organizes aspects related to the data offloading process in fog-based solutions. It's the main contribution. We defined a taxonomy, organized and structuring some aspects related to data offloading, and we also provide some guidelines to support the decision of choosing techniques related to data offloading. We try to support the decisions related to some of the later questions that I present at the beginning of this presentation. How to offloading, how which data, when. We try to give some guidelines attached to this taxonomy. Okay. Now we are going to present the taxonomy. It's the main result of this research. We try to organize it, all the knowledge related to the process of data offloading in fog computing, and we organize it then in two general perspectives. One perspective related to data. This perspective contains all the aspects related to the data that your application needs to offload. These aspects are related to the data characteristic. It depends on the application. For example, one medical application has some requirements related to the data. A smart city application has another aspect related to the data. Okay, and there is the other infrastructure is related to and the other perspective is related to the infrastructure. What it means? It's related to the infrastructure where the application is deployed. It's not exactly related to the data, but related to the infrastructure, to restrictions and the constraints related to the infrastructure where the application runs. Okay, and there are some class. We define a specific class to organize the knowledge related to the data offloading, in particular characteristics of the data, and some of them are related to the security. Okay, security is a common aspect, common requirement when we talk about the data, and we have, for example, aspects like such as confidentiality, availability, the availability of the data, or if you need now, if you need the data for the whole lifetime of the application, the integrity related to the data, the privacy. Some data have strong restrictions related to privacy, and depending on this restriction, your policy to do offloading may be different. Sometimes you need to keep the data because you cannot transfer the data, or the way how you transfer, depending of the privacy aspects. You need to encrypt it, for example, or you don't need to encrypt it depending on the privacy of data. You can use another techniques like a blockchain if you need the aspects of privacy, integrity, and you can use different techniques depending on the aspects related to these characteristics. The management is related to the way how you manage the data when you transfer or when you keep it. And you can do optimization. For example, what is optimization? You can filter some data. Sometimes you have a large amount of data, but you don't need to transfer or keep every data. And depending on this decision, you can optimize, you can compress the data before we transfer or before we store it. The replication is also an important aspect. You can replicate it in different nodes. The volatility and the critically is how relevant is the data. Volume is related to the size and the flow, how the data is produced. And the other aspects is related to the infrastructure, network, storage, processing, and the constraints related to energy. Okay, and you try to organize all this knowledge. Here I have a short time to explain everything, but in the paper we try to explain each of these factors, each of these aspects. And finally, in order to validate that this taxonomy is tangible and we can instantiate it in a specific application, we try to do a proof of concept in the context of a patient monitoring application. We use this application based on case studies proposed by the OpenFog. And the application that we choose is intelligent monitoring after surgical procedures. The problem is because medical device producing and storing data, and we have also application to clinical decision support, and the system has several alert mechanisms, generated automatic response if any anomaly is identified. We use this application to identify the requirements, and based on these requirements, we try to show how to use the taxonomy in order to help in identifying some important aspects related to data offload. It's the general idea of the application. big picture, but the most important part of the proof of concept is that we for each class, in each aspect in our taxonomy, or how you can see, for example, security management theory are classes in our here in our taxonomy, and we try to instantiate how, when, which data we do in the security management theory, each of these aspects, how we manage the data related to security, to the management, and the other one. Okay, here. And for security, for each aspect, integrity, availability, privacy, we try to explain which decisions were made, how the data is integral to integrity, availability, and for this reason, we showed that the taxonomy can help you to decide the best the best decisions related to data flow, because you have all the knowledge related to data flow organized and structured for you you to choose between different aspects. You have a fundamental base. You have a base to understand what is important when you do data offloading. Okay, and finally, this taxonomy compiles and organizes relevant aspects related to data offloading in folk scenarios. We also provided the guideline attached to this taxonomy, and we expected that these guidelines help to choose. In our understanding, we provide a powerful tool set for choosing the most appropriate techniques for offloading process. Because for each of the aspects, we try to give some guidelines how to decide that if you replicate, that how you can replicate, that how you can improve the availability, for example. And finally, in the context of this paper, we used a specific application try to show, to demonstrate that the taxonomy is tangible and helpful for compute scenarios. The proof of concept, the main object, the main purpose was only to show that we could instantiate the taxonomy, and it makes sense. It can help you to identify the main aspects of data offloading. Oh, okay. I think I finished the presentation now, and I'm open to respond any question. Thank you for the time.
Thank you very much for that interesting presentation. Are there any questions from the audience? No, I don't think so. There's any questions. I think you've explained very clearly what your research is about. Thank you once again.
Okay, thank you.
Thank you. So we can proceed with the next presentation, if the presenter is in the room. The paper by the title Artificial Intelligence and Data Science in the Detection, Diagnosis and Control of COVID-19, a Systematic Mapping Study. Do we have the presenters in the room? I see there is a fellow Jigster that joined us.
Is Veronica or Hector here? Is Walter here? No, I don't think so. We're here.
Let's just wait
Sure.
for them to show up eventually.
Is on.
Oh, I think Walter is here. Yes.
Hello, good morning.
Good morning. How are you doing?
I'm doing well, thank you.
Good.
And how
thank you.
about you?
Good. Thank you. Andrea, I think we can continue with this presentation while the presenter is here, and then we can return to the one on artificial intelligence.
Okay, it's
Are you ready to present?
Yes.
it's okay.
Okay, thank you. Please share your screen and you can commence. Thank you.
All right, just a moment, please. I have an issue with my web camera. So, can you see my screen share?
Yes, thank you. Yes, we can
Yes,
see
we
your
can.
screen.
Yes.
Yeah, thank you.
Oh, perfect, thank you. So, good morning. And I don't know what time is it there,
Well,
but
it's good morning. Yes.
yeah. Oh, perfect. So, first, it is a pleasure to be here at this conference again. I will present our research, and I hope everyone is well. So, let me introduce myself. My name is Walter. I am from Brazil, where I work as a professor at IFRN, and also I am a master's student degree at UFRN. Now I'm going to present our literature, our systematic literature review. The title is Wireless Protocols and Device Communication in the Industry Internet of Things, a systematic review. So, why we researched wireless protocols and IoT? IoT refers to Industrial Internet of Things, that concerns to possible applications of IoT for the industrial area. Industrial environment presents a particular scenario regarding the difficulties faced to concern wireless data exchange between devices. So it's a challenger for wireless communication because factors like interference, noise, and the impact of wireless communication due to physical obstacles and business needs and other specificities from industry. Based on change in the industry requirements, it's a huge demand for bandwidth, speed, data consumption, data analysis also. It is necessary to implement protocols and technologies that can cover these needs for the market. So this study aims to examine the current state of wireless communication protocols used in Industry 4.0 through the systematic literature review. As a way to achieve this goal with scientific rigor, this review was undertaken by as described by Kitchen. The review was carried out to identify the main protocols and communication architectures used specifically in wireless communication IoT, demands that are still needing investigation and in the area, and also the main challenges. So to do this, we follow these three research questions. What are the main characteristics of IoT-based wireless communication? What are the challenges and opportunities related to IoT-based monitoring application? And also, who are the main authors of the works in this area? We used these data sources and this string for search. And this review included studies published from 2017 and until 2021, excluded papers, short papers, articles, and so on. So we followed these 4 stages. And the first stage, we have found 179 papers. From these 179 papers, we read the titles and abstracts from 57 papers, and from in these 57 papers, we read 10 as a careful reading, where we read a full paper. Well, regarding the publication, the year of publication, we could notice a tendency to increase the interest in the field of research, as shown in this graph. And then we try to answer the 3 research questions. The first one about the main characteristics of IoT-based wireless communication protocols in industry. We noticed that the main characteristics are resource constraint, focus on different security mechanisms, and that the industry has specific characteristics and business needs. Then we show the applications protocols more often used as a MQTT and CoAP. The wireless and communication protocol more often used are Zigbee, especially, and LoRaWAN. Some of works propose new algorithms and protocols in face of specific business needs from industry. So 2 listed here are modifies as existing protocols as TS-CH and implementation of a new multipath PHY transmission and another new algorithms. About hard platforms, Bluetooth-based communication and Arduino-based communication was more often used. Also about the communication topologies, wireless communication between sensors and a central node, and peer-to-peer are the 2 types applied in these studies. So here we can see the frequency of occurrence of wireless protocols. As shown, the more often used protocol was Zigbee. And we show a technology view applied to as a stack of technology protocols in this figure. About the second research question, that are, what are the challenges and opportunities related to IoT-based monitoring applications in the industry? We can show the optimization of problematic factors in the different environments of the industry. The challenge that non-IP industrial wireless network faces when trying to access IPv6 networks due to compatibility or lack of compatibility in this case. The problem that few protocols aimed to the industry support IPv6 specifically. The difficulty of carrying out both the development and the implementation of systems for wireless networking for IPv6 at the industrial level due to scarcity of wireless networks with IPv6 IoT, the difficulty of obtaining gateways for industrial wireless networking, the possible inconsistency of deterministic data on the IPv6 internet, also the difficulty with the scope of monitoring what happened in the industry with IoT techniques, both for disaster prevention, for example, and for better monitoring of production, the limitation of resource at the embedded devices, which justifies the difficulty of finding alternatives for security wireless protocol. This was a frequent challenge because the resource constraint of devices really limits the types of protocols for security purpose that are used. And also interoperability challenges due to unified characteristics of IoT and also the resource constraint. So we show the main challenges in this image. And about the final research question that was related to who are the main authors of works in this area, we found 43 authors working in this area. These 3 authors appear more frequently. And the article 6 was the one with the highest number of citations. This figure shows the distribution of authors by country. As a conclusion, future work, we can show that in general, there is a great need for industries, for studies and implementations in the area, given the diverse nature of the identified difficulties and specifics of the nature of the industry sector. The industry has specific characteristics for wireless communication, depending on the suitable for business needs, such as resource constraint, dynamic discovery of devices, and security needs specifics. Also IPv6 compatibility and more. Few protocols aimed at the industry support IPv6. This one is really frequent citation. And increasingly interest in this field. So thank you. I'm open to answer some questions.
Thank you very much, Walter, for that interesting presentation. Are there any questions from the audience? Please, you can raise your hand. It doesn't seem as though there are any questions. Thank you once again.
Thank you. I'll stop my screen share.
Do we have any other presenters in the room?
I see that 2 more people joined us. Maybe someone should present the previous papers.
Okay,
Please identify yourselves.
Is it George and Veronica? Are you here? Is Hector here? No, they don't seem to be here.
So let's see if someone join us for the previous presentations, and otherwise we can go on a break, on a short break soon.
Yes, the next presentation is at 11:30, right?
In the meantime, sir, I found the logo that you asked for.
Oh, thank you very much. I can.
Where can I send it
How do
to
you?
you? Do
Okay.
you have an email? Because
Yeah, sure.
PNG
Can you type it
file.
on the chat? Can I type it on the chat?
You can write it on my private messages.
Okay.
Thank you.
Good. Thank you.
Just a reminder for the evaluation form. I know that you have to communicate to Professor Misra.
Yes, what I did was I copied the categories and I filled it on a spreadsheet, and I'll forward it to him, and we can have a look at it. Yeah, sure. Thanks.
Perfect. Thank you. Thank you very much.
Andrea, did you send it off to me?
Not yet. I'm.
Okay. All right. Okay. No problem.
Okay. I just lost the file on my PC, so I was trying to see where it was
Okay.
saved.
Okay.
All right. Send. Let
Thank
me
you.
know if you received it.
Sure. Thank you.
It's a PNG file. It shows a black background, but it's transparent. So it should be...
Okay. Okay. Then it's probably the same one that I have.
Not sure, because I tried to download it, but it's a JPEG with a black background sometimes. So this should be the correct
Okay.
one.
Sure. Okay. All right. Okay. Let me check.
Okay, then. Hello, Professor Misra. We have a break now, I guess, until 11:30. Central Europe time.
Yeah,
Do you
so
hear?
we'll actually meet at 11:30.
Sorry, sir.
We'll meet at 11:30.
Yes, yes.
Sure. Thank you. Thank you. I did get the file. Thank you very much.
Okay, it was correct.
Yes, it is.
Perfect,
It is
perfect.
correct. Thank you. All right. Thank you.
Okay, see you later then.
Thank you. Thank you. Cheers. Thanks. Bye.
Sir, just a reminder that you are sharing your screen now while working on the presentation. Thank you.
Sorry, yes. I was just testing the sharing
No
of the screen.
problem. Just I had
Is it
to
off
warn
now?
you.
Yeah, it's off
It's
now.
okay now. Yes.
Yeah, I forgot about it. All right. Okay.
So it's 11:30, and we can resume the presentations with the third session of the morning. Just wait confirmation from Professor Misra and Professor Panchan.
Good morning. Hi, Prof.
Good morning to everyone who joined us. We have anyone who can present from the first paper of this session, data extraction of charts with hybrid deep learning model. Hello?
Hello, dear colleagues.
Yes, we can hear you. Thank you very
Yes,
much.
we can.
Okay.
Can hear you and see you.
Yes, nice to meet you.
Nice to meet you too.
Thank you. Nice to meet you as well.
Okay, can I start?
Yes, you can share your
Okay, I will share my screen. Do you see my screen?
Yes, yes, we do.
Okay, thank you. So, dear colleagues, my name is Kirill Svyatov. I am from Russia, from Ulyanovsk State Technical University, and I'd like to present you our report of our work with the theme of data extraction of charts with hybrid deep learning model. So the motivation of this work is to recognize chart plots, and it can be useful for several kinds of tasks. So the first one is a reproduction of results for the further research. So we read a lot of articles, a lot of papers, and sometimes these papers are provided without source codes. And if we want to use some results for our research, or if we want to improve such kind of results, so we need to use some data which can be represented in a type of charts. So the first motivation is to extract this data from a charts, not by pixel-wise redrawing of this data, but by automatically recognize these charts. The second is reading articles for visually impaired people that can use some text-to-speech translation, but they're not able to look at the charts because the ability to see is not enough for this. And this kind of software, these kind of models can help them understand some graphical information. Third motivation is automatic analysis of articles and web pages for computer-aided understanding of text. So now we're living in the era of artificial intelligence, and we have a lot of tools that allow automatically recognize texts to make abstracts of some texts to represent the main idea. And this tool can be used for such kind of tasks. So existing approaches use 4 steps to recognize, to extract data from charts, from plots. And the first one is localization of the chart on the image. So if we have image of the page, if we have image from a book, we need to make localization of these charts on that page. And we can use a classical approach and machine learning tools that allow to make a semantic segmentation of this image, and we can define a coordinate positions of this image on the page. The second step is a chart classification. We can use a classical machine learning models that allow to recognize, is it a histogram, is it a pie chart, is it a scatter, or some other kind of charts. So this task is very simple, and there are a lot of tools that allow to make this. The third step is a text detection. So we can use machine learning models or specialized software like Tesseract OCR that allow us to extract all texts from detected chart. And the last step is a data reconstruction. and we have a lot of problems. So existing research offer an approach that use a computer aided with manual labeling. So we need to provide manual labels, or what is a lines, what is a data, what is a scaling, and some other characteristics of the chart. And existing end-to-end machine learning models doesn't allow us to automatically extract data from such kind of charts, and we offer such kind of approach. So our work focuses on the last step, is a data reconstruction, and we offer a deep learning approach to make this. What is this approach? This is an abstract model, abstract data flow that shows this kind of process. So firstly, we have a source image of a chart. Of course, we need to extract it from the image. Of course, we need to detect the kinds of chart. And we focuses only on a scatter plot, so the regular lines. So we try to recognize such kind of charts. So after we receive image, we detect is it a plot or not. After that, we make some kinds of resizing, and after that, we split the data flow in 3 independent flows. So on the first, we recognize all texts with Tesseract OCR, and there is not science, it's just a simple engineering. And we detect all text blocks with their positions. So we extract all Y labels, X labels, or some data or something else. So we extract all texts and all positions of these texts on the image. The second one is a data charts in image coordinates. So I will explain how we do that. So we extract all lines with positions in image coordinates, not in coordinates of the existing data. Third one is we generate a plot element mask. So we need to detect which part of the image is x-axis, which part of the image is y-axis, what is Y label, X label, and X points and Y points. So we need to extract, if we want to extract data, we need to understand all parts of this image. After that, we make detection, which recognized texts are the title mask, which recognized text belongs to Y label and X label. And after that, we make a scale recognizer that allow us to transform our data in image coordinates to data into the plot coordinates. After that, we use specialized recognized data multiplexer that combine all of the receiving data. And after that, we export all recognized data to a CSV file. And of course, we can recreate the plot image. So the most interesting part of this is a central element that allow us to build masks of the source image. And here you can see the result of this process. So if we have source image, so we can make a semantic segmentation of this. And you can look that the yellow part will show us an x-axis, y-axis, X label, Y label from source image, and of course it's a title of our chart, and of course it's a data that allow us to recognize which data can located on this image. We use a recurrent attention deep learning model based on UNet, and the main advantage of this model is that we use residual connections from each layers of the encoding process to decoding process, and on each layer we use attention block, which can be presented here. And it is important because this architecture of the deep learning model uses to recognize a position-specific part of the image. So if we will use a regular semantic segmentation model like UNet, it not give us a good result because it tried to detect title on any part of the image. But recurrent attention models allow us to search the most relevant position on the image for the specific parts. So we have 7 classes, and our deep learning model output 7 images with semantic segmentation that allow us to detect an area of the image which is specific for titles, for X data, Y data, X label, Y label, and axis for that part. So how can we use this information to recreate a data? So the first one is in deep learning models, it is very important to have a lot of data as a labeled data set. So it isn't possible to find open data over the internet, and we make a lot of work to generate such data set. So we use 2 ways. First one is manually labeled data set. So we build a lot of plots. Some of them we search over the internet. We build some plots from Excel, from Python, and from other tools. And we create a manually labeled data set with open tool labelbox.com. This is a lot of work, and we generate a lot of data, and we produce and we make several hundreds of images. And after that, we use an augmentation tool, and we generate thousands of images from these hundreds. And this is another software that allows us to generate such a large data set to train our deep learning model. Another part is a simple generation of Python plots, and we used fixed masks for 7 area types, and we just generate this data, and we generate right values for this data set. After that, we generate a dataset folder that contains some images for different kinds of masks. So for title, X data, Y data, and so on, so on, so on. And we use this huge data set to train our deep learning model that based on the recurrent attention unit. After that, we make a simple computer vision tool that allow us to extract a chart scale recognition. So if we have X-axis and Y-axis, so we can find a small risks, a small dots that belongs to the data points specific for our image. And we do that in the several steps. So we have a source image, we have a points masks. Point mask is just an area on the image where we have X-axis and Y-axis. So we multiply this, and we use some OpenCV tools like whole lines, and we search the longest line, and it is marked with a red color. If you see it, it's red. So we detect our line, and after that we use a simple sliding window algorithm that allow us to find all the points. After that, we have a lot of noise on the image. So if we use our mobile phone just to take photo of the image, we have a lot of noise. And after that, we use some filtering algorithm that allow us to detect only regular points on the same distance between each other. And after that, we detect a scale parameters for this point. The next step is a data extraction. So if we have some image, so on this image of the plot, we may have several plots like green, orange, and blue, and we need to make an extraction of this data from this point. And another problem is that we have a lot of noise. So if you see here just 5 colors, so first one is green, second is orange, third is blue, fourth is white, and fifth is black. Indeed, it's more than 100 colors. So if we will zoom this image, we will have a lot of colors on the image. So we built a histogram, HSV color histogram of all this image. So this histogram is from this image, and you can see how many colors we have. So we use a low pass filter provided by this formula. we use double low pass filter just to extract a color peaks on this histogram, just to detect a human readable colors, so number of human readable colors. So why it is important? If we want to extract colors from the image, we need to understand how many colors we have. And after that, we need to make a color segmentation of this image just to reduce a number of colors to extract this data from the image. So this step describes how can we detect how many colors we have on the image, human readable colors. So this is the result of this process. And after that, we just use a simple multiplexer. So we have a scaling point, we have a data for X data, Y data from text blocks. We make a recognition of this. We have a scaling of the image from image mask, and we have extracted colors. And after that, we just use a recognized data multiplexer that allow us to extract this data from the image. So this is the result of this process. And we provide several tens of experiments, and it shows us that result is about 70%. Maybe it's not enough, but we can improve this significantly just to make tuning of this process. So the possible forms of the tuning is use another model, more deep learning layers, more hidden layers in our deep learning models, or another tools just to extract this data. And we want to replace the Sirac OCR, so it is not very precise. I think we can build our own model just to make a recognition of all the texts more precise for this process. But this is a first approach that allows us to extract data, and after some tuning, we can significantly improve this process. So if you have some questions, I will be glad to answer for these questions. So this is all.
Okay, thank you very much, Carol. Are there any questions from the audience? I think you presented so well, there's no questions from the audience, but let's just give them a few minutes.
It was a nice presentation I was hearing.
Nice to meet you, Professor Mizra.
Yes, after a long time, right?
Yeah.
After the Russia, I have not seen you in St. Petersburg. And unfortunately, your supervisor is no more now.
Yeah.
Yes.
I'm glad to invite you to Russia, so we will be glad to see you in our university.
Maybe, I don't know. You have not written anything. You have not mentioned anything. So why not? Maybe after some pandemic, right?
Okay.
So how is things going on?
Yes, fine. Everything is fine.
Good. When I heard your voice, in fact, I was in a keynote. That's why I was not, I was presenting a keynote. So that's why I was not present in the last one. But I heard your voice. So immediately I say it is Akril, right? So who is the next presenter?
It's me, Professor. How are you? Let me open my camera here.
Okay, my friends are coming. My old friends. Where is your student, right?
Oh yeah, he's here, but I'm going to play a video of him.
You are going to present?
Yes, I'm going to play a video of him.
Okay, okay. You are welcome for the next presentation.
Thank
I
you,
was really, all the guys were missing to you. They know you better than me because you are chairing the SEPA, right?
Yes, yes. I hope next year I'll be sharing again.
No, it's okay, it's okay. I understand it is too early, right? And you may work for the late night. So I understand. So it is better that maybe afternoon session or something next year I will plan accordingly.
Okay, I hope next year we're going to be present at somewhere.
It's okay, it's okay. No, everybody know that you are only the chair of SEPA, so that's why. Okay, but thanks God that our old friend, you know Jay Pancham, you have met with him.
Yeah, that's Jay.
Yeah, Jay is chairing.
Good to see you again.
So we are the same guys. Yeah. Krill is also there, but I don't know the Krill is how much interested. Otherwise, I will give some session to the Krill as well. Okay. What do you think, Krill? Krill, is he around?
Yes, I'm here. Yeah.
Yeah, so from next year, you can also chair some of the sessions.
Okay. Sounds good.
Okay, maybe 3, 4. 4 is the ideal minimum.
Yep.
Continuous, it is 1 hour. It is not much. So it's okay. Please go ahead.
Okay, let me
Next
start
presentation.
here. Just a moment. Okay, I'm going to share my screen now.
Yes, yes, please.
I'm going to play here, okay, a video.
My name is Juan Matias, and I will present about the failure for healthcare systems, a systematic map. With the advancement of technological applications focused on the health context, there is a need to history process and extract information from the data used in the health area. These solutions can support decisions and optimize process, aiming to improve the service provided. In the hospital information system, the electronic health records, e-health and m-health applications have resources that can provide solutions for different contexts in the health file. These solutions can support everything from the age solutions for detecting and monitoring patients' vital signs, include solutions for test management, hospital and clinic management data, and epidemiological data. These different solutions that can be used in the health context generated heterogeneous data. This data, if integrated, better supports clinical decision making and patient care, providing meaningful and current information. However, integration becomes a challenge since the data generated is increasingly heterogeneous. Therefore, in the context of healthcare applications where data is highly heterogeneous, interoperability becomes a critical requirement to limit. And for that, the proposal of developing a mirror can be a good option. Consider the advancements in the use of technologies in the health context, the heterogeneity of data in this context, and the challenge of integration between different healthcare systems and applications. It is necessary to investigate the use of Miller on this challenge. For this, to investigate the use of Miller for healthcare systems, we performed a systematic mapping. A systematic map is a type of a secondary study that aims to identify existing research related to a specific topic. That is, to answer broader questions related to the evolution of the investigation, which can be classified as exploratory. Uh, this systematic mapping aims to understand the current state of future trends of midwifery health and in health applications and find areas for future investigations. And for this, we defined four research questions. The first research question is, what are the existing meters for healthcare systems? With this question, we want to identify the main meter solutions for healthcare systems described in the literature and understand how they promote interoperability. The second question is, what are the main characteristics of meter for healthcare systems? With this question, we want to map the main characteristics and requirements that meter solutions for the healthcare area must meet. The third question is, how are meters evaluated in the works analyzed? With this question, we intend to understand under which metrics meters are evaluated from the point of the view of uh, quality attributes such as performance and their availability to identify possible obstacles in developing meters for the health area. And finally, their question is, what are the challenges and the opportunities to develop a meter for healthcare systems? Uh, the search engine established for the selecting the studies, the works, the articles was the Service Scopus platform. The Scopus was a platform what indexes how many databases, and the source string was used was Miller and health or healthcare. In the systematic mapping, studies published in any year, provided they are written in the English language, were included. But studies, duplicated papers, articles derived from the same author and such works that do not present middle solutions, works that do not present middle solutions for healthcare systems, works do not available for download, and papers that do not uh, answer any such question were excluded by the exclusion criteria. The quality assessment of their works, uh, the first quality assessment, we we intend to answer: does the work have a clear statement of the research objectives? The second is: does the work describe well the context in which the research was carried out? And finally, the third quality assessment, are the results obtained clear? And the process of extraction, analysis, and selection of the articles was in three phases. Um, the first phase consisted on search on Scopus by the execution of the search string in the search engine. In this phase, the search on the Scopus platform returned 1,162 papers. In the second phase, the analysis of their titles and the abstracts of the papers obtained in the phase one. The analysis was performed based on the inclusion and exclusion criteria defined. And after completing this phase, 142 articles were selected. The third phase, um, we perform analysis of the introduction and conclusion of the articles selected in the phase two. The articles selected in phase two were hid to identify and select tools that answered at least two research questions defined in the protocol. In this phase, 34 articles were selected for detailed reading and final analysis. As a result, for the first question, what are the existing measures for healthcare system? We identified about um, many solutions. INCOM, a system for monitoring the patient's health ontology based health stats using the smartphone. The Cura, proposed by Eclipse Consortium and designed to be installed on gateways. The Alljoy, proposed by the Linux Foundation and provided a version for instructed features and friends app developers. The RTPS, it presents a mirror model to control information sharing in a publication subscription-based environment. A mirror-based publish subscribe pattern that defines a template for defining and enforcing refined information sharing policies in an active notification environment. The model was described based on a published subscribe meter. The Mayaha multi-platform solution based on multimodal system architecture for the integration of the different health and active aging solutions. The Health Service Bus solution based on the Enterprise Service Bus middle software architecture, which provides a loosely coupled and highly distributed approach for enterprise system integration. The SALSA solution based on the creation of autonomous agents that react to the contextual elements of the medical environment and communicate with other agents, users, and services available in the environment. The postcode, a mirror that provides operational details, being careful to retrieve patient data from device directly to manufacturers. A mirror for in-health solution focused on the data synchronization process and on reducing latency. The S-Bus solution that allows multiple forms of communication that are dynamically configurable, supporting various communications methods such as client-server and message stream. The DGA, a mirror following the European Standard Health Information System architecture proposal, implementing a distributed repository for all clinical organization and management information of the health structure, and a security meter for data images that provides a final access control, policy management, demographic filtering, and record keeping restricted to the Canadian Manitoban PH IA and DICOM standard. For the second question, what are the main characters of the middle of for healthcare systems? The first is transparent, provide transparent data integration, enable transparent data integration between different devices and applications, that data mobility between doctors, patients, users, and mobility of documents and the equipment. Data heterogeneity provides ways to treat heterogeneous data with a high level of abstraction, flexibility, and dynamics in different contexts and environments. Flexibility and dynamics provide optimized and flexible support to specific needs of each center and unit of health. The scalability provided means where applications can scale without compromising the quality of service. The reliability allow data from different centers and units to be integrated, ensure the reliability of the data involved. The security ensure the protection and privacy of the data used by doctors, patients, and users managed through access control. For the third question, how are the meters evaluating this the work analyzed? The meters are mainly evaluated from the point of view of performance, direct and indirect costs, and effectiveness. Uh, the fourth question: what are the challenges and opportunities to develop meter for healthcare systems? The main challenge is heterogeneity of the data, the different means of communication between device, sensors, and systems, the reliability, and the data security. So, the analysis showed us that there is a larger amount of media developed for the health area, but they are not entirely flexible and applicable in different contexts in their area, and therefore do not meet all of the essential requirements for media solutions for the health field.
So the opportunity to create meters for health data that use open standards such as Health Level 7 for integration and interoperability between different health solutions and that meet the requirements present in this work is still work. As future work, we intend to propose the architectures of a meter that meets all of the requirements present in this work, as well as carrying out of the implementation and analysis of a case study of the developed solution. So here I am the presentation. I thank you all for your attention and I am available for any questions.
Thank you very much for your attention. Any questions?
Why you decided to do as a video presentation? Why not?
Sorry?
Why you
Oh,
decided to for the video presentation?
because I want him to practice his English. So
Okay, so he has not presented, but he has recorded as a video, right?
yes.
It's okay. It's okay. So is everything all right out at your end?
Yes, it is. And you, sir? Everything's
It's
okay?
okay. Any questions from the audience? Pancham is there, right?
Yeah,
Jay,
sure.
please.
No, yes, thank you. No questions from my side. Thank you.
Okay, so thank you very much.
You are welcome. And I just want to remind that if you guys have any paper, we have a under Springer conference, ICIIA.
I see.
Kirill,
Yes.
are you there? Kirill, my Russian friend. I think
Yes, I'm here.
yes. What I want to say that we are like a family. And until the Professor Sonsin was there, your supervisor, any call, of any call, he had submitted his paper, all of my conferences. And this time I have not seen any of your paper in ICIIA. Why? I think I sent you a call for paper, right? For
Yeah,
another.
yeah.
Yes, you have submitted any paper,
No, I don't submit.
but if you have any work, please submit it. Still, we can consider.
Okay, I will try to write some paper. And what is the last date?
Last date has gone. Okay, 23rd is the notification date. 23rd is the deadline, means fixed deadline to notification. We are submitting. Please submit. No, you cannot write, just to check around with your students' works and other things. If you have some ready-made works, you can only do it.
No, I don't have a prepared breaks, but I think for the future conference I will submit something.
Please, okay, because this was my first of my conference when I don't have the paper from Professor Sonsin, and in fact, you are the like a son of Prof, right?
Okay, I will remember this, and for the future,
Yes, please.
I will.
Others
prepare.
as well.
Okay.
Others as well. We have a CCIS Springer CCIS conference. It is going to be in November and fully online. Okay, and if you have any works, please submit it. I have already sent call for paper for all the authors of ICCSA. It was distributed, right? You also got the call for paper from ICCSA, computational science. I think so. So for the next presenter who is present, Jay, you can take care of that one.
No, I'm presenting.
Okay, you are the presenting the third
Yes.
paper. You are welcome.
Sure. Okay, thank you. Let me share my screen.
Title page first. Yes.
Sure. Okay. All right. Good day, everyone. Thank you very much for coming into my presentation. My paper is determining the impact of plastics obstacles on Bluetooth transmission paths. And this is within a simulated environment for more accurate location determination. So I will go through a brief background, some literature on the area, and then the methodology, results, and discussion. So in terms of the background, with the proliferation of availability of many technologies for indoor environment, there seems to be new research in this area, and hence the development of and research in our in this domain as well. So also new hardware is available now with advancing technologies, and this also enables low power consumption for indoor positioning. The intention is to actually design a cost-effective indoor real-time location system, considering the constraints of an indoor environment. And this is very different from an outdoor environment where GPS location is actually used. Within an indoor environment, there are many obstacles that are encountered within the path of the transmission. And specifically, we're looking at Bluetooth transmission. And these obstacles affect the signal transmission. In some cases, most cases negatively, and in some cases, it actually increases the signal strength. The research problem is to study the impact of obstacles in the transmission path, specifically with Bluetooth low energy signals. And the way we actually did this was installation of partitions and or screens in an office environment. And the main reason to actually do this was as a result of COVID. There are many office environments that have installed partitions and screens, and in most cases we use perspex. Sorry, can you hear me?
Yes, please go ahead.
Oh, sorry. Okay. Okay. So this result studies studies and reports on the impact of perspex as an obstruction in the path of Bluetooth signal transmission. In terms of the literature, there were several other technologies that are used and were used and are still used. In terms of outdoor positioning, as I mentioned, one would actually use GPS positioning, and that would accurately locate the object in an outdoor environment, as you have a link directly with the satellites. Okay. In an indoor environment, this is very restricted. And the way you would actually do this is a combination of hardware and software. Some of the technologies that are actually used are Wi-Fi, where the infrastructure is already present in most environments, and this is commonly used. However, Wi-Fi was not designed for an indoor real-time location system. RFID is used, but it's for a very short range. And similarly with NFC as well. And in particular, NFC is for a peer-to-peer type setup. Bluetooth is actually used and increasingly used as well, but the range is limited. So therefore, one would actually consider Bluetooth low energy technology, which is very promising. The considerations that one would need to take into account in an indoor environment would be cost. Cost is an important factor because this would impact on the implementation of such solutions. The next most important one would be the energy consumption, and this would impact on the form factor of the device and the power source as well. And accuracy of location determination would depend on the environment. In some cases, you would want to determine the location within a meter, but in other cases, you might want to determine the location within an office area or within a section of a room. Detection range. This will impact on the number of readers and gateways would impact on the detection range. So let's say, for example, you want to detect an object which is very far away from the reader or the gateway. Then you would need to install repeaters that can repeat the signal and bring the signal from the node to the reader or gateway. The form factor of the device is dependent on the application. So sometimes you would need a very small form factor device, whilst other times you can get away with a slightly larger device. So it depends on the application. The lower energy consumption, and nowadays we have hardware that use coin cell batteries, and these batteries last in the region of months to even sometimes over a year. Cost is an important factor in this, and Bluetooth Low Energy has brought down the cost significantly. The same would go for the form factor of the device, and together with this, the Bluetooth Low Energy hardware is also integrated with other hardware and providing additional functionality as well. And also the data collection method is very important, and how, in particular, how often you collect the data and what data you do collect. Okay. In terms of the methodology, so we actually set up an office environment with partitions, and we use specifically 3 mil and 5 mil perspex partitions to simulate this office environment. And these type of obstructions would actually affect the signal in varying degrees. So some positively, and we observed in previous research that glass, when the transmitter is close, would actually reflect the signal, and in some cases would increase the level of the signal, therefore giving you a very different result. In most cases, obstacles would actually impact negatively, where they will decrease the level of the signal received. The low power node that was actually used is a Skylab SK-B501 single chip solution. And this is a Bluetooth low energy solution, and it's version 5 of the Bluetooth stack. In terms of the hardware, the gateway was a Raspberry Pi, which was used to collect data from the low power nodes and transmit the data to a server running Ubuntu with Postgres SQL database. The application was actually written in C# to collect this data. And the gateway captured this data and sent it off to the server as depicted in the diagram below. So the low power node would transmit the UID and the message ID every 100 milliseconds. So perspex obstacles are used in an office environment where stacked between the transmitter and the gateway. And the size of the partition was used was a 1.2 meter by 0.6 meter high. And the readings were observed with no partitions on the path of transmission, and then 3 mil, and then a 5 mil, and then a combination of both, which was placed together. The readings were observed over a 5-minute session, and this was repeated 3 times to look at the consistency of the data coming through. Now, in this diagram, you would actually see this is the gateway, and this is the length of the room being observed, which is 6 meters by 4 meters. So the gateways and the transmitters, which is the low power node here, were placed between the gateway 1 and gateway 2. And the screen was placed here in the center at 3 meters down the room. So there were 4 gateways, gateway 1 to 4, and there were 2 transmitters. And you would see from this low power node, the level transmitted to gateway 1 was minus 57 dBs on average, and transmitted to a gateway 2, which is slightly lower, but in the same distance, okay? And as you go down, gateway 3 observed minus 68, which is slightly lower, which is understandable because the distance is greater. And similarly, with the gateway, with the low power node 2, transmitting to gateway 4 and 3, which is minus 47, minus 56. Okay. Now, these results actually show no screens, right? No screens. And an average, there's test 1 result, test 2 result, test 3 result. This is the count of the level. So we have 85 times minus 60 was observed. So here, minus 55 was observed at 73 times between gateway 1 and low power node 1. And this test was actually repeated twice or 3 times. So test 1, test 2, test 3. And as you can see, it's minus 60, minus 59, minus 59. So the level observed and the number of times the level observed was very similar. And on average, it was minus 57. And here it is minus 64, minus 60. Okay. That's with no screen. And here is the levels with a 3 millimeter screen in between the path of transmission between the low power node and the receiver. So here we see it was minus 57, and with the 5 mil screen as well, it was minus 57. And with the combination of the 3 and 5 mil screens arranged together, it was minus 56. So it's very, very similar. Here, minus 64, minus 64, minus 61, and minus 64 there as well. So these are the results that were observed. So the RSSI values occurring most often were actually taken, and over a period of time, so I have studied the levels that were received, and if you take the 3 most common levels, most of the values received were within those 3 levels. Okay, so the top 3 levels were considered as is accounted for most of the received levels. Then we looked at the average across the 3 sessions of recording as well. And the level transmitted was 0 dBm. Okay, so in general, there were no significant impact measured with the combination of the screens at the distance between the LPN and the gateway. So Perspex is used as covered screens, has minimal impact, and therefore can be used as screens in the path of Bluetooth transmission. So if there were any technology that was used previous to placing the screens and afterwards, this will have minimal or no impact on the Bluetooth transmission. The further away the gateway to the transmitter, the lower the signal, and this is understandable. The results expand on previous research that was limited to a 1 meter range. Okay. And this results extend on previous works by adding the obstacles and observing the levels received between the transmitter and the receiver. Furthermore, results are observed through a combination of Perspex obstacles in terms of the thickness and the number of obstacles that are placed in the transmission path. In terms of future work, observe the impact of signal strength with the increased number of LPN and gateways. So the number of low power nodes or transmitters and gateways within a room would have an impact, and this needs to be observed and recorded. The other aspect that would need to be extended is the levels recorded through different obstacles, and in particular metal obstacles. That would actually represent a filing cabinet that is on the path of transmission between a transmitter and receiver, specifically with the Bluetooth signal. Determine how the position of the obstacle can be determined as well, and use the position determined in future to calculate the position of the low power node for improved accuracy. So I've gone on to experiment with metal obstructions, and using this data to be able to determine the position of the obstacle, and using machine learning to be able to do that. So that's the future work that's currently in progress at the moment. Thank you very much for listening to my presentation. I hope it was explanatory in terms of the objectives and the outcomes. Thank you. Is there any questions? Are there any questions from the audience?
So hello, I have one question.
Sure, please go ahead.
Yeah. What is an effect of this? So how can I use this research in my practice? So if I want to solve a problem of localization of devices, maybe located on robots or on personal devices. So how can I use the results of this research in my practice? This is the first question, and the second question maybe not associated by your research, but maybe it's a common problem. It's a problem of privacy, of localization. So if we use Bluetooth low energy devices, so how can the problem of privacy can be solved?
Okay, thank you very much. Two interesting questions. In terms of the research that was conducted, the purpose of the research was to establish whether Perspex screens that are installed very much now these days in office environments, whether this has an impact or not on the Bluetooth transmission. And it was observed within an office environment that the 3 mil and 5 mil, which is generally used, does not have an impact on the Bluetooth transmission. So if you had an environment where you were using Bluetooth previously, then this would not have an impact. That's firstly with these results. But going forward from this, if you have, for instance, a metal filing cabinet, which is now within the Bluetooth transmission path, then that would have an impact on your Bluetooth transmission. And both of these would have an impact on the location of the node that you are looking for. That next question was privacy. So privacy would come into play when you are actually trying to locate objects or people that have not given you the authority to do so. So in this case, you would actually have a node or a device that you want to locate the position of. And they would obviously give you the permission to actually do so, or you would install your own location nodes that you want to locate, for example, in for assets or for people in a hospital environment. That's the type of application that you would actually look at. But if you're trying to locate, for example, people with their cell phones, then obviously it would be a privacy issue. And I think the person would need to give you permission to allow you to locate them. Thank you. I hope I've answered your questions.
Okay, thank you.
Any other questions, please, from the audience? It was a very nice presentation. Also valuable. It is very interesting. So if you have any questions, please ask. So in absence, Jay, thank you so much. It was really a wonderful presentation.
Thank you.
So we'll go for the next presentation as well. Who is the next after you?
Mario. Oh, Mario is here, yes.
Is here?
Yeah.
Yes.
Yes. I'm going to present my screen.
Last, right? For the session.
Just 1 minute, please.
It's okay.
Okay. Hello, everyone. Thank you for joining my presentation. I'm going to talk about the multi-level fault tolerance approach for IoT systems. And a little agenda of what I'm going to talk about today, a little introduction, then we're going to talk of our approach, then we're going to talk about the operation of the framework we proposed, then we're going to talk about how we evaluate them, then we're going to discuss a little bit about what we then we conclude our work. Little introduction is the Internet of Things has attracted attention by projecting the vision of a global network of physical objects enabling connectivity among all. And this such thing made the IoT made everyday life more pervasive, personal, and intimate through technology. However, this pervasiveness came with a price. Failures on those systems can cause fatal accidents, undermining trustworthiness in public eye. So, dependability of IoT systems has become crucial in many contexts, particularly in critical domains, healthcare, agronomy, and among others. Current implementation of these mechanisms of fault tolerance in IoT are static, tight coupled, and flexible. Examples: they are designed for a specific architecture, or they do not scale beyond all solutions, or they provide solutions for specific faults, such as link failures, device failures. IoT mechanisms are concerned with handling faults normally at a single level of point of view, or do not raise concerns about heterogeneity, adaptation, and collaboration, what are the main challenges of IoT systems. However, the complexity and heterogeneous heterogeneous systems as they exist in IoT, it's hard to adopt a unified and effective fault tolerance mechanism. Then we propose the objective of this present study is to propose a novel mechanism that support multi-level fault tolerance. This approach will allow information exchange between different fault tolerance strategies, especially for error detection, error recovery, and continued service. To do so, we implement an approach called FATEMA, which is a fault tolerance event manager. The framework is presented in this figure, which consists in a set of extensible components to handle external fault tolerance events and propagate them among levels of an IoT system. It acts as a mediator, enabling communication between IoT system levels to assist fault tolerance mechanisms, aiming for failure avoidance. So, the first component is an event input channel that acts as an event broker, providing external communication interface to receive events. It supports heterogeneous communication, provide an extensible set of interfaces. The next component is event process. It acts providing event process capabilities. Support extension that resist interest in specific events to perform its computations. Some examples of process are device registration, metrics collection, system states, FATMA fault tolerance, among others. Event storage is responsible for store and recovery data. The data case can be stored locally or distributed and replicated in other Fatmas. The size should be according to the domain and system need, and is not a mandatory component, once certain devices could have process and storage limitations. At last, the framework has an event output channel, which is responsible for providing events to the external environment. It also provides extensible interface in order to support different communication protocols. So, the framework operation. It works exchanging events from the local fault tolerance mechanisms to a multi-level fault tolerance channel, and these events are exchanged by the levels in order to achieve a better fault tolerance mechanism once we know what is going on in every level of the system. So to evaluate the framework, we conduct an experiment to measure framework efficiency and effectiveness to assist error detection and continued service. We implement a smart home system prototype. In this experiment execution, we inject 2 omission faults into a device, and we evaluate them between these faults. So the objective of the experiment is to answer the following question. Research question number 1. An IoT system using multi-level fault tolerance approach is more efficient in detecting an error and resume the system to its normal operation than a system using fault tolerance techniques at a single level. And the research question number 2, an IoT system using multi-level fault tolerance approach is more effective than a system using fault tolerance techniques at each level. So to perform this experiment, we propose 2 scenarios. Scenario number 1 is using FATMA, which is we have a mobile application, we have a cloud middleware, a gateway, and 2 appliances. At each appliance, we have a set of devices, which this one is the one which we inject the fault. In the scenario number 1, we use FATMA to exchange fault tolerance events and perform a whole fault tolerance mechanism. In this scenario number 2, we have the same architecture, but we do not have the FATMA multi-level channel. The measurements collected, we have the evaluation of the efficiency. We collect error detection time, error resolution time once a fault is injected. In the scenario 1, we have a lower average of error detection by 30% in relation to scenario 2. In error resolution, we have a 90% lower time to resolve or recover a system from an error. We also measure the system availability. We have here the system availability is the experiment time minus the time of the system availability, the device availability minus time of detection of the error minus the time to recover. Then scenario 1, which the FATMA is placed, perform better, more efficiently than scenario 2. Was 88% higher than scenario 2. So demonstrating the FATMA has a better efficient in this scenario. We also measure the effectiveness of the fat mosaic. We collected the responses given by the system by each scenario. This measure indicates that despite the FATMA introduction, each system level in S1, in scenario 1, there is a low impact of the overall system functioning. See at this metric over here. It's very close one to another. Scenario 1 has successful responses were 77% higher than scenario 2. This over here. We also produce fewer failure responses and achieve more error detection rate. So these two metrics over here. So the usage of FATMA demonstrated to assist in identifying the occurrence of an error and the return decision to continue its service. The introduction of FATMA made it possible to use a proactive communication in error detection and error and resolution stages without adding any complexity to the system, which was evidenced that the exchange of collaborative messages about tolerance between the levels of the IoT system can help and improve the dependability attributes. So the conclusion. This paper that the FATMA framework presents that the FATMA framework was enabled to propagate a fault tolerance event between system levels. The multi-layer approach acts to provide an end-to-end communication channel that facilitates fault tolerance event exchange in order to minimize fault occurrence and propagation effects. Also, the frameworks facilitate system-level interoperability by providing an extensible interfaces for heterogeneous communication protocols. So, as future work, we plan to extend the empirical evaluation to a real-world scenario. We plan to extend this study to investigate the feasibility of applying a multi-system fault tolerance approach. We plan to expand FATMA event process to handle complex events and contextual information. Thank you. Questions?
Thank you very much for that interesting presentation. Are there any questions from the audience? Please raise your hand. Any questions, audience?
Is there no any question? I think it is the last presentation for this before lunch, right?
Yes, it's the last presentation.
Yes, I can confirm it's the last presentation for this session. If there are no questions, we can go on a break until
3:15.
3:15 p.m. So thank you all.
Thank you so much.
Thank you.
Jay, I think you are returning back, right?
Sure, yes. I'll be back later on this afternoon.
Okay, so have a nice day. Thank you so much.
Thank you.
Regards to your wife as well.
Sure.
I heard some of the whistling of the ghanti. You know ghanti? Is it from your home?
Yes.
It is from your house, right?
No. I didn't have anything on. No.
Okay, maybe from anybody else.
Maybe.
I thought that somebody is. It's okay. Thank you so much for everybody. Right.
Thank you.
Okay, bye-bye.
Thank you.
Are you filling the form, Jay? Are you filling?
What I did was I filled in all the details on a spreadsheet, which I can mail off to you now.
No need. But you are filling the form, right?
Yes.
And you submitted as well.
No. I didn't submit it online. I just made a record of the ratings.
Okay,
And,
okay, no problem. When you come, maybe in between we can talk. Just to send me the
Sure.
WhatsApp message and we can discuss.
Sure. Okay, no problem.
Okay.
Thanks.
Mhm,
Okay.
okay, bye-bye.